All right, guys, we are graphing linear inequalities today. It's a big class today. So we're going to go through the procedure on how this works. So if your equation is not in slope-intercept form, you're going to solve for y. So that's the song, add or subtract the x term, divide by the coefficient of y. Okay, so you do all that. And then you're going to draw your boundary line, and it's either going to be dashed or solid. And so if you look at the table, you're going to use a solid line if you have that equal to bar. That means that the points on the line are part of your solution. And then it's dashed if there's no equal to bar. And then you're going to shade half the graph. And there's some directions on this too. If it's greater than or equal to or greater than, you're going to shade up, which means above the line. If it's less than or equal to or less than, you're going to shade below the line, which is shade up, shade down. So basically that's the procedure that we're going to use, and then I'll try to explain the solutions as we go through the examples. All right, so we're going to look at the first couple of examples. Our first example is graph y is greater than or equal to negative 3x plus 2 on the coordinate plane. This is in slope-intercept form, I know, because the y is already by itself. So we can skip step one. We don't have to solve for y. So we're going to draw the boundary line. And what we're going to do is use the slope-intercept form. So the plus 2 here is my y-intercept. So I'm going to go to the y-axis. It's kind of hard to see these axes, but this is the origin. Go up 2, you put a point. And then my slope is negative 3. We can make that into a fraction by putting that over 1. So starting from this y-intercept, I would go down 1, 2, 3, and over 1, and I can keep doing that, down 1, 2, 3, over 1. I can also go back to that first point and go up 3 and back 1. And so since we have the equal to bar, we know that this is going to be a solid line. So we're going to connect this with a solid line. And a ruler would have been good, but I forgot to grab one. So we're going to try to make this as neat as possible. And that's a solid line. So these points on the line that we graphed are the points that would make the equation y equals negative 3x plus 2 true. But now we have to deal with the greater than. So since this is greater than, that means we're going to shade up, which means above the line. And sometimes this is confusing, but if I just pick a point that's on the line and go straight up, then my pencil's on the side that's going to be shaded. So we're going to shade this whole side in like this. And so any point that's either on the line or in the shading would make this equation true. So we can check our points, just pick a random point over here in the shading and put it in for x and y and just see what happens. So Colton, pick a point that's in the shaded part.
2, 3.
Okay, he picks 2, 3, which is right here. 2, 3. So let's take 2, 3. 2 is x. And 3 is y. So if I take that inequality, I'll put 3 in for y. It's greater than or equal to negative 3 times 2, because that was the x value, plus 2. And we just see if this works out. So 3 is greater than or equal to, this would be negative 6 plus 4, so that's negative 4. So is 3 bigger than negative 4? Yes, so it works. You can also try points that are on the line. So let's say I'm using this point right here, which would be 2, negative 4, and I put that in. So I could do negative 4 is greater than or equal to negative 3 times negative 2 plus 2. Oh, I'm sorry, positive 2. That's a positive 2. And so I would get negative 6 plus 2, which is negative 4, and they come out equal. So that also works. So points on the line should come out equal, that equal part of it, and then any points over here in the shading should come out bigger. And they're all solutions to this equation. All right, so I'm not going to spend a ton of time on checking points on every single one, but you need to know how to do that. So You take the points and you put them in for x and y and see if it works. All right, let's go down to the next example. So we have y is less than or equal to 2x plus 3. So it's already slope-intercept form. We can go ahead and graph it. We're going to start on the y-axis at 3. It's my y-intercept. And then the slope 2 we can make into a fraction by putting that over 1. So that would be up 2 and right 1. And we sort of run out of graphs. So to put a few more points, we could go down 2, back 1, down 2, back 1. We can continue that out to the edge of the graph. I still have that equal to on there, so this is also going to be a solid line. So you just connect the points like you normally would. The only thing that's really different on this one is I have this less than symbol, which means we're going to shade down, or in other words, below the line. So if you put your pencil on a point on the line and go straight down, you'll be on the side that you're going to shade. So we're going to shade this side. And then if you weren't sure if you did this correctly, you could pick a point and put it in and make sure that it makes it true. But since we didn't have to rearrange this one, since we were paying attention, we should have done okay. All right, so now we're going to get into the examples where we have to rearrange things. Slightly more difficult, but we've done a lot of rearranging of equations. This is really not much different. So on the next example, I do not have y by itself, so we have to solve for y. So just like the song we've done in the past, we're going to add or subtract the x term. Since it's positive x, we're going to subtract that on both sides. And that would leave me with 2y is less than negative x plus 5. If I don't have a number in front of x, what number goes there? 1. Good job. So this is just like having negative 1. All right, and then we still don't have y by itself. We've got to divide by the coefficient of y. So we'll get y is less than negative 1/2 x plus 5/2. And the 5/2 is a little interesting, but that's the same thing as 2.5. So we can just change that really quick, and that'll help us put the point on here. Normally you're not going to have to do that fraction, but occasionally it shows up. So if I start from the origin, I'm going to go up 2.5, which is going to land between these two boxes right here. And then I have a negative slope, so I'm going to go down 1, right 2, so that's going to land there. Down 1, right 2. I can also go up 1 and back 2 to just reverse it. Alright, so this is where my line's going to go. Now, since I don't have that equal to bar, that means this is going to be a dashed line. So instead of completely connecting it, we're going to draw little dashes and try to make it super obvious that that is not a solid line. You can still put the arrows on the ends, the line still goes forever, but it's dashed. And that means if I take points off of here and put them into that original equation, they will not work. But it's still a boundary line for the shaded points that are going to work. All right, so this is less than. That means we're also going to shade down from the line. So we're going to shade below the line, which is this side right here. So when you just have a less than, all of these points, if I put them in, are going to make the less than part true, but there's no equals. So the points that are on here are not going to make it true. All right, let's do another one. All right, on the next one, we're solving for y. So we're going to subtract the x term, which is 3x. Get negative 4y is greater than negative 3x plus 12. And then we're going to divide by the coefficient of y, so we're dividing by negative 4. Now, something special happens when we divide inequalities by a negative. We're going to go flip and flip the greater than, make it less than, just like we did when we were solving them before. Then I have to think about all the signs here. So negative 3 and negative 4 cancel, and I'm going to use positive 3/4 x. 12 divided by negative 4, it comes out negative 3. So now we can go ahead and graph. So we're going to start on -3 and go up 3, right 4, and we kind of run out of graph. You could sort of do one this way, 1, 2, 3, if you go out to the edge and back 4. And since this doesn't have the equal to sign, this is going to be a dashed line. So we're going to try to make little dashes here when you're connecting, and then put our arrows. And then since it's less than, we're going to shade down. And so we're going to shade this side. Okay, so that's the main idea of what we're doing if they're in slope-intercept form. The special cases are going to be the horizontal and vertical lines. So let's take a look at that. So on this, I just have x is less than 3. So we're going to start by graphing the line x equals 3, which would be this vertical line over here. Now since it's just less than, it's going to be dashed. So I'm going to put a dashed line over here where it goes through the x-axis at 3. And this is the one time when I can't use up or down because it's an up and down line. So less than, any numbers that are less than 3, if we just think about the x-axis, would be like 2, 1, 0. Those are numbers that are going to be less than 3, and so we're going to shade the left-hand side. Okay? So next page, we're going to graph y is greater than 3. So we're going to start by graphing y equals 3, except that we don't want a solid line because it's just greater than. So I'm going to go to 3 on the y-axis and put a dashed line. And it's greater than, so I'm going to shade up or down. Where are the numbers that are greater than 3? Are they above 3 or are they below 3? Above, so all the numbers greater than 3 would be like 4, 5, 6, 7, 8 are up here. I like these because these are easy. Don't have to rearrange anything. Okay, so if we look at the next one, looking at x is less than or equal to -2. So I'm going to start by graphing x equals -2, and I want a solid line since I have that equal to bar. So I'm going to put a solid line right here. And the numbers that are less than -2 are to the left. So on the x ones, this less than, greater than actually will point you in the direction you want to shade. If it points to the left, you shade to the left. If it points to the right, shade to the right. Okay, at this point, I'm going to give you guys a choice. The last 4 slides are what I usually use as practice problems, but since we have a giant class of 2 today, I'm going to let you choose. Do you want to do them as practice problems, or do you want to do them together?
Together.
Together?
Yeah.
Okay, so we're going to go ahead and do the whole thing since I have such a large class. So this is just going to go back through all the different kinds of problems that we've seen and sort of review. So we're going to start with this one. It's already solved for y. Our y-intercept is -2, so we're going to go down to -2. We have a slightly bigger graph on this one. And our slope is 2/3, so up 2, right 3, up 2, right 3, up 2, right 3. I'm just going to keep going because I like to fill the graph up. And then will this be a solid line or dashed? Solid. Because we have that equal to bar, that means the points that are on the line are part of the solution, as we saw in the first example when we were checking. So it's a solid line. And then it's less than, so do I shade above or below? Where is less than? Is it above or below? Below. Good job. They're giving me symbols instead of talking out loud. So down. So we're going to shade down on that one. I think we've had more shading down than shading up for some reason. But if it's greater than, we would shade up. Okay, so there's one more where we have to rearrange. So let's rearrange this one. So as the song says, subtract the x term, so we're going to subtract 2x, which leaves me with negative y is less than or equal to negative 2x plus 5. And then there's just negative y, so if you want to think of that as negative 1y, it's the same thing. And that gives us something to divide by. So we'll divide by the coefficient of y, which is negative 1. And when we divide by a negative, that flips our sign. So the less than is going to become greater than or equal to. The negative 2 and negative 1, the negatives cancel. We'll get positive 2x. And then 5 divided by negative 1 is negative 5. And then we can just graph. So we'll start on the y-axis at negative 5. 1, 2, 3, 4, 5. And our slope is 2, which we can make into a fraction by putting a 1 underneath. Up 2 over 1, up 2 over 1, up 2 over 1. Like this. I just like to fill my graph up. You don't always have to put quite that many. And then it has an equal to bar, so we'll go ahead and use a solid line. And since that sign turned around and became greater than, we finally get to do one where we shade up. I think we've only done one of those so far. So this is the upside. If I put my pencil on the line, go straight up, that's the side that I'm going to shade. So all of these points would make the inequality true. Okay. So then we'll look at the special ones really quick. It's okay. So this one we have y is greater than 5. So if we go to the y-axis to 5, 1, 2, 3, 4, 5, we're going to put a dashed line because we don't have that equal to bar. And then greater than means we're going to shade above the line. We're going to shade up because that's where the numbers are that are bigger than 5 on the y-axis. 6, 7, 8, 9, 10 are bigger than 5. Okay, and then one more and we are done. So on this one, we have x is less than or equal to 5, so I'm going to go to 5 on the x-axis and put in a vertical line. It's a solid line because we have the equal to bar. And then the numbers that are less than 5 are to the left, 4, 3, 2, 1, etc. So we're going to shade the left-hand side. And that concludes this lesson.